Saraswati 2.0 Podcast Talks.
Hello all again. So we are back with a more exciting podcast today where we will be sharing our success stories and future prospects. In that line, the first question is, what are the environmental benefits to the communities from the Saraswati 2.0?
Basically, we install this technology in the wastewater treatment plant itself. So it's not to the actual community. Just we want to check whether the next phase we have the actual plant, demonstration scale plant, 100 meter cube per day. We want to really check whether it works for a small community or not, what problems we face, how we can manage this operation maintenance and real equipment failure regarding different things.
Sludge management is a typical issue, and while implementing the Saraswati 2.0 project, we observed that there are emerging contaminants which are majorly get concentrated or absorbed in that sludge. So applying that sludge in the soil as a soil conditioning agent, in the long run, it can invite trouble because of this presence of these emerging contaminants and the pathogens. Pathogens may make the agriculture field not suitable for cultivation of the salad type crops, which can be eaten in the raw form. Whereas the presence of emerging contaminants and subsequent uptake of these emerging contaminants by the plants may pose a number of challenges downstream because they are coming into food chain again. So with that in mind, we have implemented the thermal hydrolysis, and we were reasonably successful in identifying fate of many of the pathogens, their destructions, or either complete demineralization or converting it into the intermediate forms, which are not that toxic as the original compound would be.
What we've been looking into is a way to further optimize the operation of the wastewater treatment plant such that it could better deal with the lack of expert operators to make sure the water quality coming out of the wastewater treatment plant meets the requirements for clean discharge or even better reuse.
The project Saraswati 2.0 has been on ground and it has been implemented. There have been a number of pilot plants installed on site. And of course, society is directly and indirectly involved. Let us know your views, what have been the social impacts of this project.
Communities have witnessed substantial environmental improvement. The reduction in wastewater contaminants have prevented land and groundwater pollution. The use of treated wastewater for irrigation has decreased the demand for wastewater sources, contributing to the conservation of natural water bodies. Moreover, the proper treatment and reuse of wastewater have minimized the contamination of local water supplies, reducing the spread of waterborne diseases, and improving the public health outcomes. And the technology's ability to reduce odor and visual pollution has also enhanced the aesthetic appeal and livability of the surrounding area.
Yeah, social means if we have a very good quality water drink, like if we have a clear water, like we have a clean water, like this is socially acceptable. They don't care about the BOD or COD. They want our social, like our people. They don't care of BOD. They before discharging to the river, where they can take the bath, where they can utilize the river water, they require something like that. And similar quality of water we achieve from this system. So for socio-economically acceptable, there is no odor, there is no problem. Similar system working in a large scale, many places in India, there is no odor and other things. Yeah, because now in India, we are launching some new programs for the small municipalities or small villages. And these things, I think we can have a sewerage system and then the treatment system. And the treatment system brings very good quality. And if we want to reuse, we can reuse it very effectively for agriculture and for other purposes also.
The success of Saraswati 2.0 has been quite nice because of their ground implementation. But this success has to be quantified as well as qualified. So we would be interested to know what kind of metrics were used to evaluate long-term success and its effectiveness in the society.
So key metrics include the quality of treated water measured by reduction in organic and nitrogen pollutants meeting the discharge standards, which indicate the effectiveness of the wastewater treatment. Then the dependency of the freshwater source for irrigation was also reduced, which is another advantage. Then the amount of biogas generated from wastewater treatment serves as a measure of energy sustainability, reflecting the technology's contribution to reducing dependence on conventional fuels. Then additionally, the reduction in greenhouse gas emission and efficient management of sludge, they are important indicators of the environmental footprint and sustainability of the technology. Together, these metrics provide a holistic view of the technology's long-term impact, ensuring that the solutions are both effective and sustainable over time. The pilot has been proved to be a cost-effective and efficient solution for wastewater treatment with lesser carbon footprint.
The main thing is the fact that they were able to treat with a relatively small amount of membrane. We're talking about, I believe that they were operating with a double-sized unit. Instead of using just one contactor, they used two contactors at a time. So they're able to treat, on the order of 2 to 3, 2 to 4 cubic meters a day with those two units, with those two contactors. And essentially, one direction that it could go would be to go and just provide more contactors to be able to treat more water.
So what's very important, I think, for the long-term success is now if you investigate the technology and you investigate it in the lab, it's not being used. It's not being, people are not getting to know it, people not using it. So one of the ultimate goals, and I think that's why the pilot sites were of very high importance in this research program, because the pilots were installed at quite a large capacity for a pilot, so 100 cubic meters a day. With that, of course, after the program is ending, these pilots should still be remaining functional. And therefore, of course, they can be operated more. They contribute at that local point, but they also serve as an example for other sites to visit, due to which, you eventually expect to get faster dissemination of new technology.
There is a saying that miles to go before I sleep. So the same goes here. Of course, the project has been on ground and we have more or less everything with whatever we need for the success. But what next? Can you tell us what are the future prospects for scaling in terms of other regions or at international borders?
The success of pilot project has demonstrated the adaptability and effectiveness of this technology in various environmental and socioeconomic contexts. Plans are underway to expand this solution to other regions in India, particularly in areas facing water scarcity and pollution challenges. We have conducted a stakeholder workshop in our IIT Bhubaneswar campus, where people from different government and private organizations have shown interest to adapt our technology in their future projects. So internationally, the technology has the potential to be adapted in other developing countries with similar environmental and water management issues. So collaborative efforts with international partners and organizations are expected to facilitate knowledge transfer, funding and technical support, enabling broader implementation and contributing to global sustainable development.
I think there are quite a lot of opportunities there. I think what I think made Saraswati 2.0 unique is that we have a whole range of different technologies that are complementary in terms of, first of all, let's say wastewater treatment, but secondary also the improving the reuse potential. I think what makes India unique is that it's extremely densely populated. So solutions that are designed for, let's say, working in Indian context have a very good opportunity of also being feasible in other regions that are less densely populated. So I think that's a very important aspect. At the same time, we've been looking at more concentrated and more diluted waste streams. So those are also, kind of being produced everywhere where people are. So with that, you also see that also in that term, the technologies have kind of been matched to deal with both these more concentrated and less concentrated streams. So I think that's also quite a big advantage of having kind of the overview of all these two technologies and comparison within one program in which we really took care to make sure to evaluate the technologies on an equal basis using the same kind of parameters throughout, let's say, all the pilot studies.
Yeah, we have very, very high potential. We can replicate it. We have and what we learned, and we are in the policy making, and we will suggest that this is the main thing for the small plants, because advanced small plants, affordable advanced. This is one of the affordable sequencing batching is one of the affordable advanced wastewater.
So we need to find out a sustainable solution for a proper sludge management. It's to not to address the problem only with the today's context, but also 10 years, 20 years down the line, we should not spoil the environment to such an extent, because these emerging contaminants, even at the microgram or nanogram per liter concentration, some of them may have much adverse effect, because some of these are endocrine disrupting compounds. So we need to care for that, and foolproof technological solution we need to provide for implementation, particularly in the context of developing countries where there is a lot more, there is a gray area where a lot of, as I said, two-third of the sanitation infrastructure is yet to be developed in India. So if we adopt technology which are robust enough, which are not having any threat, posing any threat to the environment, so that will be more sustainable.
Thank you, all the experts, for sharing beautiful success stories along with your quantitative analysis, as well as future direction and course of action where and how this project can further be taken on the more heights. Thank you, audience, for staying with us and enriching your knowledge. I hope that you all will be here with us next time. Thank you.